For most of the 20th century, Pluto lived a simple, proud life in our textbooks. It was the ninth planet, small, distant, and mysterious, but undeniably part of the planetary family. Then, in 2006, everything changed. Pluto was officially reclassified as a dwarf planet, igniting one of the most emotional scientific debates in modern astronomy. To many people, it felt less like a technical correction and more like an injustice. How could something taught as a planet for decades suddenly be demoted? To understand why Pluto lost its planetary title, and why some scientists still argue it deserves to be reinstated, we need to look carefully at what Pluto actually is, how planets are defined, and why definitions matter so much in science. Pluto, a small world at the edge of the sun's reach. Pluto sits roughly 5.9 billion kilometers from the sun, in a cold, dim region where sunlight is less than 1% as bright as it is on Earth. Surface temperatures plunge to around minus 232 degrees Celsius, cold enough for nitrogen, methane, and carbon monoxide to freeze solid. Its thin atmosphere expands when Pluto moves closer to the sun and collapses back onto the surface as ice when it drifts farther away. Despite its size, just 2,376 kilometers across, about two-thirds the diameter of Earth's moon, Pluto is far from boring. Spacecraft observations revealed towering mountains made of water ice, vast plains of frozen nitrogen, and impact craters stretching hundreds of kilometers wide. Geologically, Pluto looks active and complex, more like a full-fledged world than a cosmic leftover. And for decades, that complexity was enough. Pluto orbited the sun. It was round. It had landscapes. To most people, that sounded like a planet. What actually makes a planet? The controversy surrounding Pluto hinges on one key moment: the definition adopted by the International Astronomical Union in 2006. Faced with the discovery of many Pluto-sized objects beyond Neptune, astronomers needed a clear way to classify worlds in the solar system. The IAU defined a planet as a body that meets three criteria. It must orbit the sun. It must have enough mass for gravity to shape it into a nearly round form. It must have cleared its orbital neighborhood of other objects. Pluto easily satisfies the first two. It travels around the sun in a stable orbit, and its gravity is strong enough to pull it into a sphere. The problem lies entirely with the third requirement: the orbit clearing problem. Pluto lives in the Kuiper Belt, a vast region beyond Neptune filled with icy debris left over from the solar system's formation. Unlike Earth, Jupiter, or even Mars, Pluto does not dominate its orbital zone. It shares space with countless other objects of similar size, and its gravity isn't strong enough to either eject them or pull them in. In fact, Pluto's orbit is so unusual that it actually crosses Neptune's path. The two bodies avoid collision only because they are locked in a precise gravitational rhythm called orbital resonance. From a dynamical standpoint, Pluto behaves very differently from the 8 officially recognized planets. Because it fails this third criterion, Pluto was reclassified as a dwarf planet, a category that includes other spherical but non-dominant bodies such as Eris and Haumea. Why the decision felt so controversial? Scientifically, the IAU's reasoning was consistent. Emotionally, it landed like a punch. Pluto had been part of popular culture, education, and even identity for generations. The backlash wasn't just public. Many scientists were unhappy too, arguing that the new definition was too narrow and, in some ways, arbitrary. One frequent criticism is that clearing the orbit depends heavily on location. A body the size of Pluto placed closer to the sun might easily dominate its region, while even Earth would struggle to clear its orbit if it were moved to the Kuiper Belt. Critics argue that this makes the definition more about where an object is than what it is. Public frustration was amplified by figures like Neil deGrasse Tyson, who defended the reclassification and became a symbolic villain for Pluto supporters. The debate spilled far beyond academia, turning into one of the rare scientific disputes people genuinely cared about. Pluto as a planetary world, not a label. From a geological perspective, Pluto behaves far more like a planet than its dwarf title suggests. Data from spacecraft observations reveal layered terrain, towering mountains made of water ice, vast plains of frozen nitrogen, and regions that appear to have been reshaped relatively recently in geological terms. These features point to internal heat, slow but persistent geological activity, and a climate cycle driven by the freezing and sublimation of surface gases as Pluto moves along its elongated orbit. To many planetary scientists, these traits are not trivial details. They are the hallmarks of a true planetary world. Under this way of thinking, what matters most is not where an object sits or how crowded its orbit is, but whether it functions as a complex, evolving body shaped by physical processes. Seen through that lens, Pluto is not a failed or inferior planet. It is simply one member of a much broader family of planetary worlds that includes geologically rich moons, such as Europa and Titan. These bodies are widely respected as fascinating worlds despite not orbiting the Sun directly. This perspective does not ignore Pluto's small size or unique orbit. Instead, it challenges the idea that size and orbital clearing should be the ultimate gatekeepers of planetary status. It suggests that planets should be defined by what they are, not just by how much gravitational territory they control. Could Pluto ever become a planet? Again, in theory, Pluto could meet the current planetary definition if its mass increased enough to dominate its orbital neighborhood. Some speculative scenarios imagine Pluto absorbing a significant portion of the Kuiper Belt, the vast disk of icy debris it inhabits. In such an extreme case, calculations suggest Pluto's diameter could grow to more than 8,000 kilometers, larger than Mercury and approaching Mars in overall mass. At that point, it would almost certainly clear its orbit and qualify as a planet under today's rules. However, this idea belongs firmly in the realm of imagination rather than realistic astronomy. Accreting that much material would dramatically alter the gravitational balance of the outer solar system. Pluto's orbit is delicately synchronized with Neptune's, and a major change in Pluto's mass could disrupt this resonance, increasing the risk of orbital chaos or even planetary collisions. The consequences would be catastrophic, not just for Pluto, but for the stability of the entire region beyond Neptune. More importantly, planetary classification is not meant to be speculative or aspirational. It is based on what objects are now, not on what they might become under impossible conditions. Why Pluto still matters. Whether it is labeled a planet or a dwarf planet, Pluto remains one of the most intriguing objects in our cosmic neighborhood. Its reclassification did not make it colder, smaller, or less dynamic. Instead, it forced scientists and the public to confront how scientific categories are created and revised. Definitions are tools used to organize understanding. They are not value judgments. Pluto did not fail a test. It simply highlighted the limits of older definitions as new discoveries expanded our view of the solar system. The debate also exposed something deeply human. Many people felt Pluto's demotion personally, as if a familiar landmark had been erased from the map of the universe. That reaction shows how strongly we connect to the stories we tell about space. Pluto's story reminds us that science is not isolated from emotion or culture. It evolves alongside curiosity, memory, and our desire to feel at home in an immense and often overwhelming cosmos. If you enjoy videos that make space feel a little more human and a lot more fascinating, like and subscribe, and join us as we keep exploring the universe together.